The first thing we do with any question is to read it carefully. First of all, notice that it's in two parts, A and B. When a question is like that, it means that apart from perhaps being about the same subject, in this case curves with parametric equations, they are in fact separate parts, so we can treat them separately. But the first one is about a circle and is defined by parametric equations. That means the x and y coordinates are given in terms of a third variable, in this case theta. Now theta actually does have some geometric meaning, and that's why they've used the symbol theta there. But what we're asked to do is find a Cartesian equation of the circle. That means an equation just in terms of x and y with no theta. And the second part of the first question, we have to write down the centre and the radius of the circle. Write down. That means it's going to take us no working or anything like that. We just write the answer down and you'll notice it's only worth 1 mark. In part B of the question, this is very important. You must show detailed reasoning. The reason for this is because it is possible on some calculators to do this question graphically and to get an answer graphically, and that of course is not allowed. You've got to show how to get the answer algebraically. So that's what that caution is for there. Notice we are given a curve S defined by these parametric equations. We're not told what the curve is. When I come to that part, I'll have a look at that. And the parameter in this case is t. Although it looks very similar, it's in terms of sines and cosines. In the first part, the parameter was theta. In the second part, the parameter is t. And the reason for this is that in the first part, theta does actually have some geometrical significance, whereas in the second part, the geometrical significance is not quite as obvious, and in fact t is just a real number. So t of course has to be in radians, and that's made quite clear there. We have to find where the line L, which is a tangent to S, crosses the x-axis. We'll come to all of that in a minute, but first of all let's now analyse the first part of the question. In order to find the Cartesian equation of the circle, we need to somehow eliminate theta. And the way forward is to isolate theta from each of these two equations. The first one giving cos theta as x minus 3 over 2, and the second one giving sine theta as y plus 4 over 2, and using the relationship cos squared theta plus sine squared theta is always 1. So we get x minus 3 all squared over 4 plus y plus 4 all squared over 4 is 1. X minus 3 all squared plus y plus 4 all squared is 4, which we should recognise as the standard equation of a circle. Centre 3 minus 4, radius 2. Now, although that is quite sufficient to score us the full 3 marks, and it is not required to go any further, I am actually going to draw a diagram of this to explain the equation of the circle and to help explain the next part of the question a little easier. So we know that the centre is 3 minus 4, so what we're really looking at is the fourth quadrant, and 3 minus 4 is about there. So if we draw a circle something like that, that's a circle of radius 2, centre 3 minus 4. I'm going to draw horizontal there and consider that as a general point P, and that radius is 2. C is the centre of the circle, which is 3 minus 4, And if that angle is theta, then you will see that the x-coordinate of P is the x-coordinate of C, which is 3, plus 2 cos theta. If we go up to the question, x is 3 plus 2 cos theta. And the y-coordinate of P, that side is 2 sine theta, so the y-coordinate of P is minus 4 plus 2 sine theta. Go back to the original equation, minus 4 plus 2 sine theta. So this angle, theta here, this angle actually represents the angle between CP and the x-axis. And as theta increases, so P will move round the circle. As P moves round the circle, theta will increase. So in this particular part of the question, the theta actually does physically represent an angle on the diagram. It's not so much the same in the second part, as you will see. For the second part of the question, we need three skills which are not given in the formula booklet. The first is a knowledge of the trigonometric ratios of pi by 6 or 30 degrees. If you can't remember them, you can very easily find them for yourself by drawing an equilateral triangle of side 2, splitting it into two congruent two congruent right-angled triangles, and working them out from there. For example, cos pi by 6 is the same as cos 30 degrees, which is root 3 over 2. Similarly, sine pi by 6 is the opposite over the hypotenuse, which is a half, and tan pi by 6 is the opposite side over the adjacent side, which is 1 over root 3. You'll notice there that I was using degrees. That is because when you're working out the sine, cosine, or tangent of an angle, it doesn't matter whether you're working in radians or degrees. And I find, particularly when dealing with a geometric figure such as this equilateral triangle, to think in terms of degrees. The second skill we require is a knowledge of the chain rule for differentiation. And there is the chain rule for differentiation. Now, we are told that dy by dx is not a fraction. It isn't a fraction. It might look like a fraction, it might taste like a fraction, and it almost certainly smells like a fraction, but it's not a fraction. But the best bit is it behaves just like a fraction. So dy by dx is dy by dt times dt by dx, and dt by dx is 1 over dx by dt. So we're going to need to find dy by dt and dx by dt and divide the two to get dy by dx, the gradient of the tangent at the given point. And then having done that, we will need to know the formula for the equation of a straight line through the point x1, y1 with gradient m, and that is y minus y1 is mx minus x1. Now we come to the solution of part B. Now I'm going to call the point where t is pi by 6 P. So at P, t is pi by 6, and we need first of all to find the x and the y coordinates. X would be 4 cos pi by 6, and cos pi by 6 is root 3 upon 2, so x is 2 root 3. And y is 2 sine pi by 6, which is 2 times a half. Sine pi by 6 is a half, which is 1. And so we know that P is the point 2 root 3, 1. And that is the point we're trying to find the equation of the tangent. Now, the gradient of the tangent is dy by dx. And by the chain rule, we know we need dx by dt and dy by dt. So let's find them. Dx by dt is the derivative of 4 cos t, which is minus 4 sine t, and dy by dt is the derivative of 2 sine t, which is 2 cos t. And so dy by dx, by the chain rule, is dy by dt divided by dx by dt, which is 2 cos t over minus 4 sine t. 2 and the 2 will divide into the 4, and that can be simplified to minus 1 over 2 tan t, or if you prefer, cot t, minus cot t over 2. But I'm going to leave it as minus 1 over 2 tan t, and we can now find the gradient at the point P. dy by dx will be minus 1 over twice tan pi by 6, which is 1 upon root 3, and that tidies up to minus root 3 upon 2. Now we can find the equation of the tangent at P as y minus y1, y minus 1, the y coordinate, there we are, y minus 1 is m, the gradient, minus root 3 upon 2. We found that down here. And x minus x1, x1 is the x coordinate at P, which is 2 root 3. We can tidy that up a bit, multiply both sides by 2, and multiply this bracket by minus root 3 3x plus minus 2 root 3 plus, oh, where did that come from? Plus 6. And that finally tidies up to 2 plus root 3x equals 8. 2y plus root 3x equals 8. Now, we don't need to go any further with that. We're not asked to find the tangent. It's just part of the process. So we can now carry on to find where it cuts the x-axis. This cuts the x-axis where y is 0. That is the equation of the x-axis. So root 3x would be 8, and x would be 8 over root 3. So the point it cuts is 8 over root 3, 0. Now, you can leave the answer as 8 over root 3, 0. You could multiply top and bottom by root 3 and give 8 root 3 over root 3, 0. Or you could, if you haven't been using root 3 upon 2 and a half, but have been using your calculator, you can give the answer, but it's essential, it's correct to 3 significant figures. So you can give the answer in decimal form as well. Well, there we are. I'm quite pleased with my answer, so I shall underline it. Now, before I give the mark scheme for this question, let's just look at a little bit of background. If I were teaching a lesson based upon this example, I wouldn't just do the worked example and say, there you are, that's it. I would try and add some background material or explain some of the more difficult points. And that's exactly what I try and do in this video. So before I give you the mark scheme, let's just look at the second part of this question. You will notice in the first part we talked about a circle, and we were given parametric equations of that circle, and we had to find the Cartesian equation of the circle. In the second part, we were given a curve S. Similar parametric equations, in fact they look very similar indeed, but subtly different. Notice that that 2 is the same there, whereas this has got a 4 there and a 2 there, and that makes a subtle difference. But it's a curve. You're not told what the curve is. You don't need to know what the curve is. But I'm going to go a little bit further and explain exactly what this curve is. If we look at the parametric equations that we're given and proceed exactly as we did in the first part of the question, cos t is x over 4 and sin t is y over 2. And using cos squared t plus sin squared t equals 1, we get this equation, which is the equation of an ellipse. Now, an ellipse is studied in the further maths syllabus, but not in the single subject syllabus. But the examiners get away with it by just calling it a curve and giving you the parametric equations, which is part of your syllabus. It's interesting that this particular year, 1920, all three major exam boards had a very similar question, which was a question on an ellipse, but disguised by the fact that it was just called a curve. Well, this is the Cartesian equation of an ellipse. When x is naught, when x is naught, y squared is 4, so y is plus or minus 2. And when y is naught, x squared is 16, so x is plus or minus 4. That helps us to give a very quick sketch of the ellipse. And I have drawn the tangent at the point P, which we were given, where t was pi by 6, 4 cos pi by 6, 2 sin pi by 6, which, when converted into decimals, comes to about 3.461. And you'll see P there has coordinates of about 3.461. And the tangent at P is shown there meeting the x-axis at Q, which we were asked to find, and the answer was 8 over root 3, 0, which in decimal form becomes 4.620, which is about right. Before I have a look at this particular clip, an apology. In the previous clip, I referred to the date when the examining boards set almost the same question on the ellipse without calling it an ellipse was 1920. I may be an old mathematics teacher, but I'm not that old, I assure you. Anyway, in this diagram I have drawn a circle of radius 4 in addition to our ellipse. That circle is called the auxiliary circle, and you'll see that it crosses the x-axis at exactly the same points as the ellipse, but of course it crosses the y-axis at different points. That circle has a very similar equation to the equation of the ellipse, but with the exception that that 16 has become a 4 in the ellipse, and it is that which causes the difference. Now let's look at our point P. As P moves round the ellipse, so the point directly above it will move correspondingly around the auxiliary circle. The points will actually coincide at the 4 places where the two curves cross the main axes. This line here has no real geometrical significance, as I explained earlier on, but if you consider the point directly above P on the auxiliary circle, then that line does make the angle pi by 6, and there is the geometrical significance of the pi by 6, not on the ellipse but on the auxiliary circle. Now on to the mark scheme. In the first part of the question there are 3 marks available, and 1 mark is for correctly using cos squared theta plus sin squared theta equals 1. And you get an accuracy mark for getting the right Cartesian equation. Remember, accuracy marks always depend on method marks, and so you do have to show some working here. There is an independent mark then for the writing down the centre of the circle as 3 minus 4 and the radius as 2. Now if you were unfortunate enough to make an error in writing down an equation, and suppose for example there you wrote x minus 7 squared, for example, you would still pick up that you would lose this accuracy mark, but you'd still pick up this final mark here, providing, of course, you followed it through from there. And now the mark scheme for part B. The first method mark is picked up for correct use of the chain rule here, and the corresponding accuracy mark, which depends upon that, is for getting the actual gradient dy by dx minus 1 over 2 tan t. Any of the alternatives would be acceptable, like minus cos t over 2 sin t or minus a half cot t. And then another method mark for substituting pi by 6 correctly into whatever you got for dy by dx. This is a method mark, which means it depends upon whatever you got for your dy by dx. In other words, for substituting pi by 6. We then try to find the tangent at P, and you get another method mark for trying to find the tangent, providing you use whatever gradient you got here and the correct coordinates for whatever you got for P. You can write any rubbish you like for P and any rubbish you like for the gradient. If you use the equation of a straight line correctly with whatever you got for the gradient and whatever you got for the point P, then you would pick up that method mark. You would, of course, lose accuracy marks later. The next mark is a method mark for putting y equals 0 into whatever equation you got for the tangent. And finally, the accuracy mark is for the final answer, 8 over root 3, 0. You are, of course, allowed, as I mentioned before, various equivalent alternatives, including correct to 3 significant figures, if you wanted to give. Well, there we are. Quite a long question, but I hope you found it useful. Many more similar videos are planned, and if you want to be notified of each new release, all you have to do is to subscribe to my channel. It's absolutely free. If you head across to my website, fredthemathematicalfly.com, you'll find many other A-level questions discussed in detail, together with a set of graded exercises relevant to each topic, and plenty of interesting and occasionally amusing background material. But until the next video, goodbye and good luck with your mathematical studies.